All right, in your note packet, it has 3.7 and 3.8 combined. That's an extremely long lesson, so I'm actually breaking it up into two different lessons. So let's go ahead and just do the first part. Let me go ahead and click on this and pick a color. Okay, so we are going to be doing 3.7 today and 3.8 tomorrow. So 3.7 is going to be having to do with lines on the coordinate plane. So we have talked about lines and points and things like that in our geometry class quite a bit, but we haven't really focused on them on a coordinate plane other than when we were dealing with the distance formula. What we're going to do is do a little review over the stuff you should have learned in Algebra 1. So all of the stuff in this section and the next section should just be review. But since it is part of the standards for geometry, for high school geometry course, we are going to cover it again. So the start thinking part says you're going on a bike ride with a buddy. You're a little concerned because he says that there's going to be a hill. What are some questions you might ask him about the hill? Now, I've actually done this with one of my buddies, and he did say there is going to be a hill, and I started thinking, oh, am I going to be pedaling like crazy, and I'm going to be sweating like crazy, or is this going to be like a joy ride? And a big part of that had to do with the question that I had to ask him was, is the hill uphill or downhill? So let's say he went over and says that it is uphill. There's another question I'm going to ask. I'm going to say, how steep is that hill going to be? So you have these two different aspects here. You have, is it going to go up or down, and how steep is that going to be? Now, these two things can be talked about as something called slope. So you learned about slope in pre-algebra probably and in Algebra 1, and it's a number that is either positive or negative, telling you whether it's going up or down, and then it's going to have a number like the actual value of the number is going to tell you how steep that's going to be. So slope, which they call m of a line, is going to be how steep the line is. Now, what you need to know is that slope is going to be rise over run. If you think about a point, when a point is rising, it is going to be changing the y coordinate. So that is going to be change of y. And when a point is running, it's going left to right, that's going to be a change of the x value. So slope is going to be rise over run, which is change of y over change of x. And that is going to be y from the second point minus y from the first point, all over x from the second point minus x from the first. That does not mean y squared, that means y2, y from the second point. So when you are looking at something like this, you can also, rather than picking points and using the formula, you can just count vertically and horizontally. Counting vertical and horizontal on a graph is very, very easy to do. So in this case, the rise is 2, the run is 2, so the slope is going to be 1. That seems weird though, because 1 means 1 over 1. Well, if you look at this, there's another point right here, and that is rising by 1, running by 1. So 2 over 2 is the same thing as 1 over 1 when you simplify. So when you are looking at a diagram, you can kind of just count to find out what the slope is. And when you have points, you're going to have to use the formula. So let's go ahead and calculate the slopes here. Now, it is very important that you label these x1, y1, x2, y2, because if you don't do that, you're going to think that the first one is all x's and the second's all y's, or you're going to do some weird pairing. On here, y2 minus y1 all over x2 minus x1. 1 minus 10 is -9, and 7 minus 3 is 4. Now, we usually don't go over and change that into a mixed number, 2 1/4. We usually leave it as is, because that'll tell you to go down by 9 and right by 4. Whereas if you did have 2 1/4, let's say, that's going to be kind of hard to figure out how much you're going up and over by, or down and over by. Now you got to be really careful because you have a minus already in your formula, and sometimes you're going to have negatives. So you're going to have minus negatives. So x1, y1, x2, y2. That's going to be -4, and by default you put a minus, and then you have your 6. And the other one is going to be 4, and you put minus by default, and now this is a -1. Just because you have a minus here does not mean that the negative is not part of the 1. So you end up getting -4 minus 6, which is -10, and then leave change, it gives you 5. And you end up simplifying that to -2, or -2 over 1. Now, if you are having trouble with negatives, the best thing that I do is I think about above water and below water. So like -4 would be you are 4 feet underwater, and then it says you drop by another 6 feet. So now you are 10 feet underwater. Whereas, let's say you had -3 plus 5 or something. I'm just making these numbers up. That'd be 3 feet underwater, and then you're coming up by 5, which is going to put you in the positives or above water. So this is probably my favorite way to deal with positives and negatives. It's basically the number line, but vertically. I'm happy to work with anybody if you're still struggling with negatives. Now, whenever you are given something like this, you need to hunt out pretty points. So this is a pretty point that goes right at the intersection of the horizontal and vertical lines. Now, this is not a pretty point. That's not a pretty point. This is the next pretty point. So those are the 2 pretty points that I found. So you find out your rise or fall when you're going from left to right. So this is falling by 2, down by 2, and it's going over by 3, over by 3. And that gives you a slope of -2/3. Let's say you missed this pretty point and you went straight to that one. Well, don't worry, that would be down by 4 and then over by 6, which reduces to -2/3 as well. So as long as you pick pretty points, this is not a pretty point, that's not a pretty point, you have to find those nice pretty points where the intersection of these lines are. Okay, now there are these special slopes that you have to be really careful about. If you have a horizontal line, there's a few different ways you can do this. While you're going from left to right, are you going up or are you going down or neither? Well, on a horizontal line, that is going to be, it is not going up or down, so it's a slope of 0. Okay, it's actually a slope of 0. If you picked points, let's say you pick these 2 points, how much you rising by? Nothing. How much you running by in this case? 2. And 0 divided by 2 just gives me 0. So you need to know that a horizontal line is always going to have a slope of 0. Now a vertical line, on the other hand, if you're going from left to right, what's happening? Is it going up or down? Well, this is tricky because it's not going from left to right. And if you did think of this going left to right, which you can't really, but if you did, is it going up or down? Well, it's doing both. Vertical, you could be climbing up it or dropping down it. So that's a little tricky. The special name for this is undefined. And let me show you why that is if you actually try to calculate the slope. On this one, what is the rise? 2. What is the run? 0. And what you need to know, if you try to put any number divided by 0 in a calculator, it just says error. You cannot divide by 0. It's one of the big rules in math. You cannot divide by 0. So every vertical line is going to have a slope that is undefined. It's supposed to be a comma right here. So once again, if you were calculating the slope, x1, y1, x2, y2, you would have y2 minus y1 over x2 minus x1. That is going to give you 6 over 0. Is this 0 or is it undefined? Another way you can remember this is the 0 is underneath, so it's undefined. Now if we look at this one, x1, y1, x2, y2, you would have y2 minus y1 over x2 minus x1. That gives you 0 over 2. Now that's totally fine. You can go over and have 0 divided by 2. You have 0 things and you're putting them in 2 different bins. How many equally? How many are going to go in each one? Well, 0 of them are. The reason why this gets tricky is they say you have 2 things and you're putting them in 0 bins. Well, how can you put 2 things in 0 bins? You just can't do that division. So this one would be a 0 slope. Nothing wrong with doing 0 divided by a number. So just remember, if it is horizontal, it's going to have a 0 slope. If it's vertical, it's going to have a slope of undefined. So we are kind of baby stepping into here. We're talking just about slope, and then we're going to talk about the equation of a line. So let's go ahead and talk about this one. Graph to equation. Now, the most useful, I think, equation of a line is in y equals mx plus b form, where m tells you the steepness, its slope, and b is your y-intercept. Here's your y-axis. It's just asking where does your line cross through that y-axis. Now, when you're visually looking at a graph, this is rather easy, because you just put a y equals, you can pretty easily calculate a slope. If those are your 2 pretty points, it's up by 2 and over by 1, up by 2, over by 1. Then you have your x. And then visually, you're able to see your y-intercept. Your y-intercept, where does it go through the y-axis? At 1. So this is the equation of that line. Okay. And what that means, don't forget about what an equation is. An equation is basically a point generator. If you went over and made a table of values and were generating points, you picked your x's and got your y's. Say you said 0, 1, 2, 3. Whenever you substitute these values in to find out the y value, so if you substituted 0, it would be y equals 2 times 0 plus 1. You'd have y equals 1. This pumps out, your equation pumps out points. Every single one of these points makes this equation true. And if you plot all of those points, you end up getting a line. So that is the connection between an equation and the graph of it. The graph is the visual interpretation of all of the solutions, and the equation is kind of the rule which can create all of the points that are solutions. Now, we just went from an equation to a graph, and now, or actually we went from equation to graph. We went from a graph to an equation, and now we're going from a equation to the graph. Once again, not way too difficult if you actually know the different parts of an equation. The part connected to the x is your slope, and this is your y-intercept. So this tells me, where do I go over and start? Well, I start at -4. That's where it goes through my y-axis. And this tells me to go up by 1 over by 3, up by 1 over by 3. And you always want to take a second to ask if your answer is reasonable. We can see you have a positive slope, which means up from left to right. 1/3 is not super steep, and your equation of your line is not super steep either. So that's how you do it. You find your y-intercept, and then you move away from your y-intercept, and that would give you the visual interpretation of all of the points that make your equation true. Now the other one, you have a y-intercept of 1. You need to make sense of what that means. You need to know that that is the same thing as -2/3 x. So this, what I like to do is I bring the negative up top always. So if there's a negative, I bring it up top in the numerator, and that tells me to go down by 2 and over by 3. Or up by 2 and over by 3 in the other direction. Any way so that when you're going from left to right, it's going down. There you go. Now don't forget, we had just talked about how y equals a number is going to be horizontal, and x equals a number is going to be vertical. We're going to graph those in just a second, but then it gets confusing when you have this. What is y equals x? Is that vertical or is that horizontal? Well, when you think of this as just y equals 1x plus nothing, that becomes much easier. That's just saying start at 0, y-intercept of 0, and go up by 1 over by 1, up by 1 over by 1, up by 1 over by 1, down by 1 over by 1, and so on. This is y equals x right here. Okay. If you're writing the equation line, two things you need, as we talked about at the top of the page, is you need to know your slope and your y-intercept. For your slope, you just pick two pretty points. In this case, we're going down by 3 over by 1, so you have y equals negative 3x, and then you can see your y-intercept visually is at 5. That's as easy as it is. Find out your slope, find out your y-intercept, put it into an equation. We talked about earlier that did I talk about, let me check. I forget if I told you about the x equals versus y equals. I did not. So all I did up here was I told you that the slope of a horizontal line is 0 and the slope of a vertical line is undefined. But I didn't tell you how to write the equation. Sorry about that. So as I alluded to, x equals and y equals are either going to be vertical or horizontal. And it's actually rather easy to figure out which one it's going to be. If your line goes through the y-axis, it's going to be y equals. If it goes through the x-axis, then it's going to be x equals. So since this is going through the y-axis at 1, it's just y equals 1. If it was vertical and going through the x-axis at 1, you would say x equals 1. So hopefully that makes sense. X equals is vertical, and y equals is horizontal. This is all should all be review from Algebra 1. Okay, the next one really quickly, and then we got to get into writing the equation line given points and slopes. This is going to be a slope of up 1 over 1, so it's y equals a slope of 1, and you can see that it is going through the y-axis at negative 3. So there would be the equation that corresponds to this graph. Here's the equation that corresponds to that, and so on. Now what we're going to be doing now is I'm going to give you a slope and a point, and you need to figure out what the equation is. If I gave you the slope and a y-intercept, it would be super easy. But visually what this is saying is I'm going to give you a slope. Let's say a slope of 3. That could be any one of these lines. These are all going to have a slope of 3. But the difference is the way we lock into a single line is it's going to also go through this point. So you're going to have a point and a slope, and algebraically, you're going to be able to find out what that y-intercept is. I'm going to show you two different ways to do this. The first way is by solving for b. So what that means is go ahead and write the equation. Y equals the slope 3x, but you don't know what the y-intercept is. So this is not the y-intercept. This is just some floating point. Now the beauty of a point that is on the line is it has to make your equation true. Any point on the line must make the equation true. So when I substitute this in for x and that in for y, it better make it true. And if it doesn't, then we're going to have to add something or subtract something from the right side. So 5 is going to equal 3 times 1 plus b. Right now, it's just 5 equals 3, which is false. So you're going to have a b value that is going to make it true. You can either guess and check and say 3 plus what equals 5. It's obviously 2. Or you could go over and just solve for b, hence solve for b. And that would give you 2 equals b. Now you're at that point where you knew what the slope was, and you know what your y-intercept is, and you're able to circle it and be done. Now point slope form, let me show you what that is. We know slope is y2 minus y1 over x2 minus x1. Now what we're saying here is you're only going to have 1 point. So this whole nonsense about 2 points goes away. So its slope equals y minus y1 over x minus x1. And if we wanted to get the y stuff by itself, we could multiply by x minus x1 on this side and by x minus x1 on that side. So what that does is it gives you point slope form being y minus the y coordinate equals slope times x minus the x coordinate. That's called point slope form. Now, if this didn't make sense, just know that this is point slope form. So let me show you how you can do the same thing that we did here in method 1, but with point slope form. So you can say y minus the y coordinate is 5 equals the slope 3 times x minus the x coordinate. Now that is a perfectly good answer in point slope form. If you wanted to go into slope-intercept form, you would just distribute 3x minus 3, and then you would get the y by itself. And you can see that you end up getting the same answer. I don't care which way you do it, just know one of those two methods. So we're almost done here. So on a problem like this, remember, for the most part, I'm gonna be solving for b. So, because that's what I'm comfortable with. You'd say y equals mx, you don't know your b yet. Now all you have to do is substitute in your point and solve for b. So you have negative 6 instead of y equals negative 2 times 3 plus b. Negative 6 equals negative 6 plus b. Well, it's already true, so that means b is just 0. You could also just solve for b, and you'd say 0 equals b, which means your equation is y equals negative 2x plus 0, or just leave it alone. I'm going to do the next one, but with point-slope form, just so that we can practice. Remember, it is the variable y minus the y-coordinate equals the slope times x minus the x-coordinate. And that's perfectly fine if they just want any old equation. But if they actually want to have if they want slope-intercept form, then you'd have to distribute in, getting you 2/3 x. And then that gives you 2 times negative 9 is negative 18 over 3. I just said 2/3 times negative 9. Y minus 2 equals 2/3 x minus 6. And when you add 2 to both sides, you end up getting y equals 2/3 x minus 4. And that would be the same equation as if you solved for b, whichever one you guys are comfortable with. Now, the time that you can't solve for b is when you have a problem like this. This is saying that it is going to be undefined, also known as vertical, one of these vertical lines, but it's got to go through 2, 3. So you have to go through a thought process. Undefined means vertical. Vertical means it goes to the x-axis, which means that it's going to be x equals some number. And what it is going to be is x equals 2, because that's what the x-coordinate is. If it was y equals, it would be y equals whatever the y-coordinate is. All right, just one last thing. It's just one extra step, and then you guys don't have these proofs on yours. If they give you 2 points, you know that you need to have the slope and you need to have the y-intercept. So you have neither of those things right now. So what you need to do is first calculate the slope. So let's do that. x1, y1, x2, y2. 13 minus 3 all over 3 minus 1 gives me 10 over 2, or 5. Well, now you have that slope. So you can write out y equals 5x. You just don't know your y-intercept. And then the step that we did next in the problems above was we picked the point, and substituted in the x and the y. But now you have 2 points to pick from. So you say, which one do I pick? The answer is either, whichever one looks prettier. That doesn't look as pretty as this one. So I can now substitute in y being 3, x being 1, and we just solve for b. And you see that b is negative 2. And that means that you have the equation y equals 5x minus 2. Okay, the next one is pretty much the same type of problem, so I'm going to skip it. I just want to show you one more funky problem. Now in this one, when you try to calculate the slope, you do 7 minus 7 all over 5 minus 2. Ooh, this is weird. This gives me 0 over 3, which is a slope of 0. So how do I substitute that in? How do I solve for b when I have a 0? Well, technically you could just say y equals 0x plus b and then substitute in a point, but it's not that easy when you have, like, if this came out to be undefined. So just you have to go through a thought process. A 0 slope means it's going to be horizontal. A horizontal line goes to the y-axis, which means it's just going to be a y equals a number. So it's going to be y equals the y coordinate and the point. Which point do I pick? Sorry, not that one. Y equals the y coordinate. Which one do I pick? Well, lucky for us, they are the same. You get y equals 7. And then kids always say, well, what happens if they weren't the same? How would you know which one to pick? And the answer is you wouldn't have gotten a slope of 0 in that case. If this problem ended up being a number over 0, that would have been undefined, which would have been vertical, which would have been going through the x-axis, so x equals the x coordinate. But that's if you got undefined. We got 0. Okay, that was a lot of information there. It should have all been review from Algebra 1. Just make sure that you guys know how to calculate slope, write the equation of a line given a graph, and then also graph a line, which we did right here, and then write the equation of a line by solving for b or using Poitt's slope form. That is it. Thanks for watching.